Welcome to those of you who've joined so far. We're going to get started in just a minute here. There are a few others who've registered who haven't yet joined. Let me go ahead and start sharing my camera, turning my camera on so you guys can see me. Um, Maybe what we can do is use this time while others are still joining. I've been encouraged to introduce myself rather than just launch right into the content whenever I do a webinar. So to try to take that advice here, I'll use this time right now to introduce myself. Um, thanks for joining. I'm Alec Walker. I've spent a lot of time with Excel over the course of my career so far, probably similar to many others. And I have a chemical engineering background. I got my bachelor's in science in chemical engineering from Rice University in Houston, Texas, where I am right now. I also got my MBA from Stanford. I worked for Shell for about 4 years and moved around a lot inside of the company. And when I when I did, I moved not just inside of the same function, but I was lucky in that I was able to kind of see lots of different sides of the energy industry from inside of one humongous company that does all kinds of stuff. Um, and Excel was featured across everything. It was just kind of like the uh, the tool for work. And I'd used Excel in college, but um, I used other tools as well in college. But it wasn't until I got to the workforce that I realized the extent to which Excel was just ubiquitous. And I had lots of work to do, whether I was in refining and downstream doing turnarounds and external consulting, or even doing internal software creation inside of Shell, if that was my role, or being a reservoir engineer in upstream, trying to find oil and gas and figure out the best way to organize its extraction. Regardless of where I was in the organization, I was doing tons of work that involved Excel. And a lot of that work that was very time consuming and kind of tedious, so there's an interesting part of my job where I was actually like doing some thinking and trying to like analyze some data or apply some skills that I had learned in my undergraduate degree or skills that I picked up through training or just through work experience. Um, that kind of work uh, was really interesting, but there was also a lot of work in Excel that was just kind of rote. Like I had to open up a file and drag something somewhere and get something to work in a certain way, and really repetitive. And the majority of my time was spent in that second category, doing that kind of work. And it wasn't just me, I saw that all over the company. And I thought, well, if I have extra time, I should learn how to try to automate some of that. So that's what this talk is going to be about. I've kind of transitioned from introducing myself to starting to talk about the content. So I'll finish introducing myself here in the last couple minutes before 9:05 Central U.S. time, while I'm still admitting people into this webinar. To finish introducing myself. So after Shell, I told you I got an MBA. I then went to work helping big organizations, typically multinational organizations, to empower their workforce to be more productive. And a lot of that was about recognizing opportunities for innovation and setting up systems and incentivizing people to be entrepreneurs inside of their own companies. And a lot of companies like that. So they'll set up some kind of program where if you discover an idea that, could lead to innovation, the company will give you some opportunity to go pursue that and see what you can do with it. And if it works, then they'll find some way to house it inside of an existing business unit. So I did a lot of work helping to enable that sort of thing. And that was kind of more on the design thinking and entrepreneurship side. And then on the hard skills side, I wound up doing a lot of work teaching people how to automate and expedite their workflows. So, you don't have to have a huge step change in technology to enable more efficiency and more productivity inside of your firm, you can just train people how to scratch the surface doing some scripting to automate parts of their work. And it actually goes pretty fast. It's pretty easy for people, especially with technical backgrounds already, geoscientists or civil engineers or whatever it is, to pick this stuff up and start to make a big difference there. So I'm going to go ahead and get started now. I've just been kind of filling the time trying to introduce myself and give some context to why I'm giving this talk. This is what I plan to cover today. Ordinarily, when Inly is doing anything, it's really interactive. That's become harder because it's, COVID-19 era and we're all separated from each other. So this isn't an in-person workshop where we can interact and in the same exact way. But also because I'm using this webinar to introduce a course that Inly is teaching, I want to get a lot of the lecture out of the way and a lot of the context out of the way ahead of time. Because in the course, we make things a lot more interactive, even though it is an online course. So I plan to go for the first hour or so, meaning the next 54 minutes or so, going through these 6 points. And then at the end of that, I'll open it up for questions generally. In the meantime, though, and I'll try to keep to whenever I finish one of these 6 blocks, I'll pause for a little bit and look at the chat that's in Zoom here. Just pulling it up. There it is. Where if you want to post a question, just go ahead. So if a question occurs to you and you don't want to try to remember it all the way through the rest of the talk to the end, just type it in the chat, and then I'll be looking at that periodically so I can try to answer it during the webinar. All right. So yeah, thanks again, all of you, for joining. I think a few more will trickle in as we go here. So I'm talking about automation of work in Excel. So I want to start with an example of that. So let's say this is our example. Our job has to do with interpreting some sort of data here. And this data I just grabbed, it could be any profession, it could be like legal or medical or, finance or something like that. But in this case, I just grabbed some information that's like geology information. And I made this up, so it might not be accurate. So if you're a geologist on this webinar and you see that the Paleocene is, perhaps deeper or shallower than 7,000, I don't even know what units that is, feet or meters or something. Don't worry about that. That's not the point. Instead, I want you to think about your own workflows and whether there's some overlap in what I'm talking about, not in the data, but in the workflow itself. So let's say that what you need to do is open up a bunch of files. And for each file, you need to grab this data and then consolidate it into a single table in this master table thing down here. So let me zoom in a little bit. We need a single master table to go underneath this row 20. So this is just an example. There's all kinds of workflows that people do like this. So you'd have to open the file, and I've already got them opened and I've created tabs here, but you'd copy it and then you'd paste it into here. This is typically how people would do this. And then they'd open the next one and they notice it's somewhere different. Okay, it's like, starts on line 11 instead of line 4 or something like that. And they'd grab this one and copy it and then come back to the master table and paste it here. Okay, and then go in here and open this and copy it. And I've got to be really careful that I don't accidentally just grab part of it. I need this whole thing here. Otherwise, I'm going to be missing data. And then I paste it in here. But I'm not done. This is a mess. I have 3 header rows. And I also see that there's some overlapping data. And I made that very simple to see because I gave everything a sample number. So here's sample 5. It's Permian at 8,200, and here's another 8,700. If I compare that Permian, which is number 5, to this Permian, which is number 5, I see that it's exactly the same. So if my goal was to create a single master table here, I got to do things like go in here and delete this, go in here and delete this. And then this is a 5 that overlaps with this 5. Here's a 2 that overlaps with this 2. So I need to delete all those overlaps. And that might take a little bit to find. And maybe I didn't do a perfect job as a human if my data is not just, however many points this is, 12 points, 11 points, something like that. What if I had like 1,000 points? And what if I had to open not just 3 documents, but 1,000 documents or something? So this is typically where like people start to bump up against the boundaries of just using Excel as a visual and data manipulation tool, the way that you've got right here in this screen, and where it starts to become more practical to do something with scripting to automate your workflow. So if I click this little happy angel here, I just get that right away. That just happens for me automatically. And that's because I built this little tool that will do that for me. So that little tool looks like this. It actually looks like, yeah, it actually looks like this. So it's not that long, and don't be intimidated by what looks perhaps like gobbledygook if you don't have experience with writing software. This is actually something that you can learn in like 10 hours or so of concerted effort, maybe less. Um, maybe 8 hours of concerted effort and 4 hours of fun exercises just to kind of make sure that things stick. And so that's one example of how you might save a lot of time. You click one button and it takes the same amount of time no matter how much you've got here. Within reason. If you have 1,000 files, it might have to process for a little bit longer, but it's still one click of a button, right? And because you wrote it, because you're the one who created this little tool, you own it and you understand it. So it's not a black box for you. For you, it's part of getting your job done. And typically what happens, and I'll get into this more in the next section, is if you start writing things like this, you're not alone in your firm having to do this workflow or workflows like this. So if you create tools that people are using to expedite their workflow and get stuff done really, really fast, then not only are you responsible for the success, the improvement of the whole team, but also you own that process. So you become indispensable and everybody like wants you around because if they have questions about it or they encountered an error or something, you can explain it and help fix it. And overall, things go a lot faster and there are a lot fewer errors once you start changing your workflows like this. So that's one example. I'm going to move on to the next part. I have another example to show you, but I might wait till the end to see if we have time there. I'm looking at the chat just to see if there's any questions so far. Yeah, go ahead and hold them if you want to, or you can just type them in as I'm talking. So that was an example of automated work. Let's move on to Excel's place in our workplace. So if you read the description of this webinar, I said I'd be talking a little bit about context for Excel as a tool, including its history. So I don't want to spend too much time on this, but it's kind of interesting. So Excel, as we know it, wasn't the very first tool to try to represent data in the form of a spreadsheet on a computer. So in accounting, a long, long time ago, before I was born, people used spreadsheets in physical world on paper as opposed to on computers. And they looked like this. There were like lots of little cells and you could, write in designated places, you could write in numbers and then do calculations based on how those numbers were oriented in comparison to each other. So you have like a grid and you write in some numbers and, then like I need to add these parts together. I need to multiply these parts together. And these two geniuses here, great idea, Dan Bricklin and Bob Frankston, came up with a program that would allow you to do that same thing on a computer. And it's pretty like hard coded, like, you can't drag things around. All you can do is enter in different balances and see where, pay, check, and deposit, whatever the original format was of a spreadsheet. I'll share this presentation at the end so you can click through these links if you're curious. It was for the Apple, whatever that is, Apple II, maybe, Apple bracket. And that's what that kind of computer looked like. So when these guys invented VisiCalc, it was a big deal. And the press releases on it talked about how this is definitely going to sell the PC. So PCs before this program weren't like household kind of things. They were like, you had to be somebody like Bill Gates to have one. it was a big deal to own a PC, and the only way to interact with it was to spend a ton of time like coding. So it wasn't very practical if you just wanted to like get one to get your work done, because the learning curve was so steep and so prolonged that like who would bother when you just have work to do. So the concept was, wow, this is going to be really easy. It's going to sell the PC and it's going to eliminate the need for coding. So people can just like, if they already know how to do a spreadsheet, they can just do it on the computer now. So that was exciting. Microsoft came along with something called Multiplan in 1983 that resembled VisiCalc. And so this was the predecessor from Microsoft to Excel. And when they finally came out with Excel in 1985, this is what it looked like. And you can see it's got the row and row and column headers here that we're used to. And then here's a macro. This is that code that I was showing you. So Excel had VBA, Visual Basic for Applications, where you can create code kind of like this from the start, from the very first version of Excel. And what ultimately happened, which is kind of interesting, is VisiCalc kind of faded away as Microsoft's Excel kind of took over. And rather than selling the PC, it actually sold the Mac, because early Excel was for Mac and was really popular for that reason. So anybody who needed to do work with numbers and have a calculator that kept track of the numbers and that allowed them to arrange those numbers in two-dimensional space wanted this tool. So it really sold the Mac. But rather than eliminating the need for code, it actually popularized coding. And so what happened was people who needed to get work done by moving numbers around and manipulating them in Excel wound up learning all about Visual Basic. And so Visual Basic was a really big draw to Excel. And people who didn't have any coding experience fell in love with Visual Basic and started to do a lot of coding to expedite whatever work they were trying to get done in Excel. So I don't know what happened after that, but it became less and less popular for people to learn about Visual Basic. I don't know if schools stopped teaching it or what, but it's remained just as useful and just as relevant to anybody who's doing things in Excel. So a little bit more about Excel. Versions of Excel up to 7.0 had only 16,000 something rows. And now you can see I scroll to the very bottom of a new Excel file here, and you can see that there are a lot more rows. So version 8 through 11, it got bigger and bigger, so 65,000, and then there are a lot more columns. And now version 12 onwards, we're dealing with over 1 million rows. So it's starting to become possible to do bigger workflows in Excel. A lot of people are starting to use other tools because Excel was still built for visualization and was originally designed to be like a executable file on your hard drive as opposed to like a cloud native tool or something like that. But hey, it's showing improvement here. Like Excel is now capable of handling quite a lot of data. And with modern processors, as I'll get into, you can do quite a lot with Excel and not have to worry so much about the limitations of how Visual Basic is a little bit like clunky or takes a long time to execute. So just a quick little thing about Excel Online. I'm sure those of you who use 365 for Office 365 and the cloud versions of Microsoft products have seen that there are some new features and there are also some like things to complain about. So I'll share these links here, but if you go into them, just really quick here, you can see different like categories for complaints and suggestions. And I think it's cool of them to call it complaints and just own that rather than just call everything suggestions. But and you can see macros, scripts, and add-ins there. That's one category there. Microsoft Excel Online resembles Excel for your desktop, your laptop, the actual hard drive installation version of it in a lot of ways. One of the biggest differences, however, is that there is no Visual Basic. So, that's kind of frustrating to many. So back to the presentation here, if you're using Excel online and you have to use Excel online, currently you can't execute macros. There's no Visual Basic. Maybe that will change soon, but actually most of us who are using Excel are not using it online. So here's some interesting global Excel stats. This is something I got from the Microsoft website. Number of users in 2020, it's not the end of 2020, but they had, around 750 million. That's a big deal. And it's the most important Microsoft product, says the CTO or CEO of Microsoft there. So, more important than Teams, more important than, any of the newfangled things that they're offering, Azure. They still consider Excel to be the most important Microsoft product. So that gives you a sense of how ubiquitous it is. So why is that? Why is Excel so popular across the world? And first is data storage momentum. So what I mean by that is across tons of different industries, people are using Excel to store their data. So if you want to access your data, you got to double click on some kind of Excel file somewhere that contains your data in it. And the process of taking all of that and moving it somewhere else would be like a huge hurdle. And so people don't really do it. It's kind of like when Google came out with Google Plus as kind of Google's answer to Facebook. Actually, Google Plus might have come before Facebook, but regardless, Facebook had all these users and Google wanted all those users from Facebook, but nobody wanted to move into Google Plus because they would have to take all of their friends with them, take all of their network with them. And it's kind of hard to reset that way, right? So that's what I mean by momentum. And in this case, it's not like, where's your community online? It's like, where are you storing your data? If you're storing everything in Excel already, then, because of that legacy of having done that, there's a lot of momentum and you're going to keep doing your workflows in the same way and keep storing your data in Excel. So thousands of petabytes of new data in Excel per year, claims Tulip. So I'm just grabbing stuff from Tulip. I've kind of heard of this group. I don't know how reliable this is, but I think that like the point is still relevant, even if the numbers are a little bit off here. So you can see broken down by sector how much data per year is stored in Excel. And this is amazing. So thousands of petabytes, let's just break that down. A petabyte is 2 to the 50th bytes, or 1,024 terabytes. My hard drive on this computer that I'm using is like a fourth of 1 terabyte. So, we're talking about 4,000 times my hard drive is just 1 petabyte, but we're dealing with thousands of petabytes here. So this is a really, really big number. There's a lot of data that's stored across different industries in Excel. So that's one reason why everyone's still using Excel, why it's probably not going anywhere anytime soon. Another, user experience momentum. So it's not just about like, where's your data stored? It's also about, for the individual people who are using Excel, how much experience do they have with it? So it's a little bit harder to find this information online. So I actually did a survey through my other company, Delphin. We do unstructured to structured data conversion, mostly for oil and gas companies. So they give us like tons of PDFs and, compliance documents and manuals and maintenance documents and field notes and things like that. And we extract the data that they care about from that and put it into formats like Excel. So I'm not allowed to share our client names here, but we mostly deal with oil majors, and we have experience working with independent operators and service companies and private equity and energy industry professional societies. So lots of energy industry kind of stuff here. And when we asked them we asked, the people who are our clients on the teams that we're helping, how many decades of experience do you have with Excel? This is what we got as answers. So this is in percentage, by the way. So this adds up to 100 here. So we have like a third of the people with around 20 years of experience working with Excel. That's a long time to be working with Excel. And there's some people who've been working with Excel, rounded up to around 40, which is like since Excel was brand new, since, the 80s, when it was a brand new product. So people are really used to using Excel, and they're very comfortable thinking in terms of getting work done in Excel. So when they have a sense, all right, I need to get this work done, they're already thinking about like, just intuitively, naturally for them, they're thinking about doing it in Excel. So the average here is 23 years of experience across our clients. Pretty interesting. So those are the two reasons why I think Excel is so popular right now. So workflows are Excel centered. That's the main point. Something else interesting to show here is a little bit about the complaints that people are starting to voice and the challenges that they're facing still dealing with Excel in the contemporary workplace. And when I say contemporary workplace, I mean rapidly accelerating, accelerating in terms of new technology adoption, accelerating in terms of the expectation of productivity, um, accelerating in terms of the expectation in terms of your ability to manipulate data and access data across your company in order to then manipulate it. Use machine learning techniques to inform the decisions that you make with your data, having gathered that data from across the company, that sort of stuff. And so because we're all still using Excel, we kind of run up against some things that maybe like, a while ago were just sort of par for the course and now are becoming more and more like pain points for us. So here's an example that I just grabbed from Reddit back in July. So a really archaic spreadsheet at work for years, which is used by about 20 people to input scores for suppliers. And again, don't worry if this scores for suppliers part doesn't apply to the kind of work that you do. That's just fine. The point is that, pick your workflow and then see if the complaint is otherwise analogous. So there's a different workbook for each year, a different sheet for each month, a ridiculous amount of columns, 3 per supplier. Maybe there's 1,000 suppliers, so 3,000 or so, I don't know. And some hideous graphs that only populate after days worth of copying and pasting. You can imagine the mess it's in at the end of each month. So here's somebody else's response. I used to find Excel really restrictive. It's a lack of knowledge that restricts us. And what they're talking about there is Visual Basic. Like, you can do things in Excel using the built-in scripting environment that take problems like this and just delete them. You don't have that problem anymore. So I'll show you another example at the end, but let's keep going with the presentation for now. A few others just joined here. If you have questions, you can just enter them into the chat box, and I'll be looking at that periodically throughout my presentation, throughout this webinar. So what about other business intelligence tools? Like, who's going to come along and usurp Excel? And by business intelligence tool, what I mean here is some kind of tool that's not based around you scripting. So Excel is still based around like this graphical or table interface here. So we have a grid and we can like organize and manipulate data. If I type in a number here, I can grab it and move it somewhere else. That's what a business intelligence tool is. It's something that like you can tell it, hey, I want to do this with my data. I want to do this and see what's happening and what's going on. And it'll like move things around for you. So here's an old joke from the business intelligence community. What's the most used feature in any business intelligence solution? So somebody has sold your company, $30,000 a year subscription to some kind of fancy business intelligence software. What are people going to use the most in that business intelligence solution? The export to Excel button. So typically there's some kind of button that these tools have that let you click and export whatever data you were dealing with into Excel. And the reason this is a joke is that like, if you're using that business intelligence solution the way it was meant to be used, then you wouldn't need to export to Excel. So like everybody is still just using Excel for everything, even if the format they get the tool in is in some other business intelligence solution or something like that. So what do experts in Excel predict? This was published back in 2016, I believe. So these people, I'll share this again. You can look at the article Invest in Tech. So if you don't know the names that I'm pasting in here, that's okay. You can research it later, but just like take for granted that these are people who have done like, big things in Excel, enabling others to be more productive or, teaching courses or things like that. So this guy, Ken Pohl, says, I personally see Excel as the future of business intelligence workflows. I truly believe Excel is here to stay, says Brad. Excel will be right where it always has been, at the center, says Chris. Will be the go-to software to analyze, chart, and tell a story about your business, spotting trends, etc., says John. So these people who are really deep into Excel can't imagine Excel going anywhere else. Personally, I think Python is going to come along and just kind of like usurp Excel. But in the meantime, knowing both is really the best thing to do. But in the meantime, if you just get good at Excel and learn how to script in Excel, it's going to be like kind of a long, slow decline there, unless Microsoft does something big to revamp it. So I disagree with these four things, these four quotes, in the long term. But I think in the medium term, like the next whatever 5 years plus, Excel is still going to be a really big part of our workflow. So there's a lot of background there. Rather than intersperse that in the course, I thought I would just like put it on this webinar. Not only will I share these slides with everybody who attended here, I'm also going to share the video. So I'll just post this on YouTube when it's done. So everyone can kind of check that out if you want to. So when I share the slides, you'll actually have access to these links here. All right, so next up, what's happening in the market? This slide is super zoomed out. Don't worry about that if you can't read all of the detail here. The point is to look at these blue dots and then consider that this is a log scale, and then these are increments of 2 years. And what we're looking at is the number of transistors on an integrated circuit chip. The average integrated circuit chip is, if you were to take an average for each year of these various points and, draw that line, the best fit line, it would kind of, go through all of these points here as best it could. And what this is called Moore's law. And this guy Moore came up with this because he noticed that every 2 years, the number of transistors on a circuit chip doubled. And that's held true pretty well to 2018. So it's a pretty cool predictor that he noticed sometime a while ago, and it's mostly held true. So we're getting more and more integrated circuits, more and more transistors on our integrated circuit chips. They're getting smaller and smaller as a result. So what does that mean? It means that most computers now can. This is an additional thing that has become possible because of this. More computers contain more than one processor. So instead of just having a single processor that's doing your work and spinning around trying to make things happen for you, you have 2 or you have 4, quad core or 8 processors in your computer. And essentially what this amounts to is that doing more computationally expensive tasks, including data science methods that were much more sort of theoretical and academic before, takes a lot less time now for everybody, not just for academics, for anybody working in the industry. And I think this helps to explain why data science is becoming so popular. But it also helps to explain why there's kind of no excuse not to be doing more scripting yourself. If your computer can handle running Visual Basic for Excel, then why wouldn't you be doing that? Like, what is holding you back? It's certainly not the fact that your computer will crash when you try to do it, or when you hit go, it just takes too long and you come back the next day and it's still trying to process and move things for you. And you'd say, oh, to heck with it, I'll just do it myself, manually. No, it's really fast now. And it's just getting faster. It's becoming easier and easier to manipulate data on computers programmatically. So that's what should be happening. It also becomes cheaper is another interesting point here. So, my laptop is really cheap and costs less than $600, and it does just fine with this stuff. So there's kind of no excuse anymore from Moore's law. Another interesting just kind of background here, I found this from a presentation that Hess, the energy company, gave yesterday. And they got it from Visual Capitalist here. So I'll share this. You guys have the link too. But this graph shows, this is percentage of people who are using a technology. And then this is the date. So we see as we move from the past closer to the present, certain technologies increase in their adoption. And some of them like have decreases and then increases again. And you can kind of look at these technologies. These are considered old technologies now, but in the history of humanity, in the history of science and engineering, these are still pretty new. So running water, you can see that just got more and more popular. Everybody loves running water to where like pretty much 100% of people are using that. Stoves, hey, they got a big growth rate there and then kind of leveled out. Automobiles, there were some times when people were using automobiles less, maybe around wars or something, and then it kind of grew again. So you can kind of see these technologies here. This is, I didn't do any data analysis. I just stuck a line in here because I'm not trying to be super accurate. I just want to make a point that this is kind of the slope. So it takes, a certain number of years here. It looks like about 100 years for the average technology to go from 0% adoption to 100% adoption from 1900 to 2000. Here are some more recent technologies that bring us closer to today. And what you notice with these technologies, like microwaves or cell phones or tablets or smartphone usage, is that the acceleration of adoption has increased. So we're going now from the 50s to the 80s, like 30 years, to like 20 years to like 10 years or 5 years. So it's kind of like the pressure on people is to like hurry up and adopt new technology whenever it becomes available, right? So if we're lagging behind in technology that has been available, that's really useful now, there's less and less room for that, there's less and less in just like a capitalist economy. The people who are using this new technology, the companies, the entities that are using this new technology are going to outperform, and there's less room for that slack. So you really have to adopt it or fade away. And I don't need to zoom in too much on this. I'm sure we're all plenty aware that COVID-19 has had a severe impact. This is U.S. information from the Bureau of Labor Statistics that I just pulled in last night. This report, this PDF is great. It's huge and there's a lot of interesting stuff in it. I don't want to dive too deeply into that. I want to talk more about the course in just a sec here. You can see like US unemployment was around 4% for a really long time until it totally spiked, and it's come down a lot. Good, good for us, I guess, here in the US. But this is still, even if it had just gone, kind of this straight line up from there to here, this would still be really, really a big deal. It's more than double what it's ever been, in the last 2 years at least. So people are getting laid off and furloughed and given their salaries reduced, and times are tough. And part of the reason for that is that some people haven't adopted new technology or become stewards and champions of new technology in ways that would have made them more competitive. So that brings us to the next point. How do you stand out professionally? If that's the backdrop, you have a sense of the place of Excel and what's happening in the market generally. What does that mean for you, and what can you do to get ahead? And of course, I'm going to be pointing you towards automating your workflows in Excel. So these are trends that I've noticed in my consulting work. I've noticed when I've been working with big companies, whether it's like Intel or Sheraton, the hotel company, or General Motors, the big car company. Like, I've noticed this across lots of different companies and lots of different industries. So this is more my opinion, but it is backed by my experience. So rather than pull this from online somewhere, this is my doing a lot of synthesizing myself and trying to boil things down in ways that make sense and really feel true. So the first thing, I think, people who are really efficient in getting work done tend to get ahead. People who are data-driven, and that typically means are able to use data science methods to their advantage, tend to get ahead. And people who are versatile, who are like looking around at like what other value can they add, and where else can they find things to get good at. Those folks tend to get ahead. So for efficient, I'm talking about automating repetitive tasks. So that's a big part of it. Reducing your human error, which comes with automating. So if you can build computer programs that do things for you, and they find something and put it where it needs to go, they're never going to mess up and paste it into the wrong thing, into somewhere other than where you told them to paste it. So as long as you're careful up front when you're creating a script to do something that's, automates your workflow, then it's set after that. It'll always do it the same way. It won't make mistakes. The only mistake it could make is if you made a mistake in the coding, which, you learn how to debug, you learn how to like edge case test, and then you're set. So combining and eliminating workflows, that kind of comes with this efficiency. Something that I've seen is that people who get good at this, um, when they're done automating their workflow, maybe it used to take me like 5 days to get work done during the week. And then it went down to like 1 day to just like go through and I want to run this thing. I want to look through it. Okay, that looks correct. I want to run this thing. Let me put that in there. Now I'm done with my work for the week. So I start taking on more work. And it's not like I am being overloaded. I'm personally doing the same amount of work. I'm putting the same amount of hours in each week, but I'm getting a ton more done. And typically I start to move away from just doing the stuff that was in my job description to starting to do things that overlapped with other kinds of initiatives that the company had and didn't have time for, or creating new initiatives. So that's what I mean by combining and eliminating workflows. And on this data-driven stuff, I'm thinking like there's three parts to it. You have to make sure that the right data is captured. So you can't really be data-driven if you don't have any data to look at. If there's no data to drive your decisions, then it doesn't matter what data science methods you have at your disposal. So, in the oil and gas industry, for example, there are a ton more sensors now than there ever used to be. So we're keeping track of all kinds of things, the power usage from a pump, the extent to which the walls of a pipe have been thinning or have been building up fouling or something like that. We're capturing all kinds of stuff with sensors. So hey, that's cool. But it's not just about capturing that data. You have to like make it accessible. So where is that data being stored, and do you have access to it if it could help you when you're trying to inform your decisions here? There's a lot of siloing in traditional industries. And so it's hard to get access to data, and not necessarily even sensitive data, just data generally is stored on somebody's hard drive and they're on vacation or something like that, as opposed to being like centrally accessible and nicely labeled and easily discoverable or something. So you got to kind of work to overcome those things, and you can be a champion of those changes inside of your organization. And then this is another part that is actually not hard to learn: the use of modern data science methods. So for especially people in technical fields, practitioners who are knowledge workers is really the way I should say it. Like if you're a lawyer or you're an accountant, you can definitely learn modern data science methods. They are not hard. They're as hard as algebra, right? And I'm not saying this to sound arrogant. I'm trying to do the opposite. I think that like data scientists somehow have become so like revered in society right now that there's this sense that you have to be some kind of like super genius who was a super physicist in high school and graduated from college at age 15 or something like that, in order to even try to start doing this stuff. That's not true. These methods were inaccessible to lay people. I shouldn't say lay people, like people who weren't studying data science with access to supercomputers in academia. This kind of stuff wasn't accessible. Machine learning methods weren't accessible to anyone other than those kinds of people for a while, just because of Moore's law. Like computers couldn't handle doing those methods in the past, but now they can. So, you can learn this stuff, and you don't have to have a job title of data scientist to use data science to get work done better in your company. You can use this stuff all over the place in all kinds of industries. So that's the data-driven part. And then the versatile part, I think of this as being like a habit. So when you finish your job, do you have more energy? If you don't, what can you do? What kind of changes can you make in your life so that when you're done with the work that is expected of you, you have leftover curiosity and time to explore what else is going on in the world, like what's happening, like joining a webinar like this or somebody else's. And then how can you learn more about it? And then how can you add value in those places? So if you discover a trend, something is growing or changing and it's exciting to you, perhaps you can apply your skills to that. And the more you can kind of spread out your influence, you're kind of like hedging and you're ready. If something grows, you can be a part of that. So I think these three things have really set some folks aside. And this automation of repetitive tasks and this use of modern data science methods are two things that will be covered in the in Inly's course. So I'll move on to talk about that now. All right, so what to expect from workflow automation in Excel. So the first part, we're gonna talk about the scripting environment. You saw me pull it up here. So if I, like ordinarily, if I just open Excel, I've got file, home, insert, page layout, formulas, data review, view, and help. If I right click up here, I have to go into customize the ribbon. And then there's something called developer that I can check. And don't worry, I won't do this kind of stuff so fast in the course. I'm just showing you that like it's a little bit hidden. Like you don't just open Excel and like immediately this coding environment pops up. I'm not quite sure why that is, but my guess is that Microsoft wants to make Excel seem really non-intimidating, You just put numbers in places and like everyone can relate to that. You just start typing and you're seeing results and things are happening the way you expect. Versus if you were to open up something like this, you'd be like, what is this? I don't even know what this stuff means. So to sort of make it more visually appealing up front, they kind of like hide things from you. So the developer tab you have to enable before you can open it. So then you can click on Visual Basic and pull up this scripting environment. And you can save scripts in different places on related to your worksheets that are open. So this scripting environment is something you have to get used to. Like, how do you set it up? And where are files stored and how are they affiliated with Excel files and that sort of thing? And then how do you actually operate it? So if you wanted to change the name of a script you wrote, or if you wanted to make it execute when it opened, things like that. That comes with the scripting environment part. Next up is your basic proficiency in coding. So this is also something that people tend to be very intimidated by. When I've done consulting for big companies in the past, and there's been part of like, the innovation drive is teaching people this stuff, their company makes them do it, so I don't have to go market it and advertise it to them. Because I've come in as a consultant, like I'm put in some position where people are like, are forced to attend a class, right? It's part of their job now. Like they've been told they have to do it. And at first I thought this is going to be really tough because people are intimidated by this stuff and they don't even want to be here. And I was pleasantly surprised and continue to be. Like it's not hard to learn how to do basic stuff. I think to get really, really good at coding to the point where like you are ready to be, some senior data scientist or chief architect of a really fast moving software company or something like that. That's hard. That's really hard. But to get good enough to make a huge change in the work you can do, the work you're supposed to do or the work you want to do, that's not hard. So you have to learn about what are different types of data, words versus numbers, things like that. And then scripting commands. If somebody says, oh, maybe we should use a for loop for that, you need to know what a for loop is, or a while loop, or an if statement, and how those things are different from each other. And they're not hard to learn. It's just logic, if this, then that. Like, no, you got it. That's the concept. And then subroutines are what scripts are called for the most part in Visual Basic and Excel. So if you write a subroutine, it's something that executes when you hit play or however else you tell it to execute inside of Visual Basic, as opposed to writing like a function that's that operates by typing in an equal sign here and then using some sort of function like, I don't know, length of something. So that's a function, whereas this stuff in here is a subroutine that we're writing. That's why it's called a sub up there at the top. All right, so that's the second part of the course. The third part is we actually get into the workflow automation with a bunch of examples. So you'll be working across multiple files. You'll learn how to do some data analysis as well as like data cleaning and processing and manipulation kind of stuff. And you'll also learn this very useful time-honored skill of pseudocoding. So if you're going to write something that's a kind of a longer subroutine, like something that I showed you in in here that just like does this automatically depending, or regardless of how many tables you have and what rows they start on. This one starts on 6, this one starts on 11. If you just want something that'll go in and grab all of them and delete any repetitive rows, but with a single click of a button, you might want to write like a pseudocode for that first, where you kind of write out the logic on a whiteboard or on some paper or in a Word document or something like that before you actually start coding. And that's a really useful thing to learn how to do. And then finally, you could work on your own project. So you can select some kind of workflow that you're doing at work. Make sure you get your company's permission. Typically, if you don't share your company's data with anybody, it's okay to then share, hey, I'm trying to like in general move data around and combine it into a single column, or I'm trying to move this and do that. That's okay. What's not okay without permission is actually sharing your data, your company's proprietary data with somebody else. So you can actually bring in one of your own projects from work into this course, and we'll work on it together so that you can automate it and put your skills to use and really feel like this is a practically useful course even before you leave. So you'll create your own milestones, and then you'll begin acceleration that I think you could continue after the course is over. Um, so I've also been encouraged to talk about how Inly is different from other educators. The first thing I want to say is we teach remotely right now. I love to teach in person. I think like people come with a lot more energy, and there's kind of this somewhat nervous tension that like you're actually there and you're on the spot and others are there seeing you for real rather than just on a camera. But because of safety reasons, we're teaching remotely now, through Zoom. So there's some net gain and convenience because now we can teach all around the world, and pull students together from different places all at once. But there's this additional challenge of keeping the course engaging. So how do we keep it engaging? And I've been pretty happy so far that our other ways to keep it engaging continue to work, even though things are now virtual. So the first way is that the course is synchronous. What that means is it's like a live course, like this webinar. You're not watching a recording of me that I've like pre-recorded, whoever is teaching, often it's me, is like just there and in the Zoom call with you. So that means you can like interrupt with a question, or you have this sense that like what you're getting is live, and that tends to stimulate people more when they know that everyone is having to think on their feet. There's this like social awareness of that and a little bit of social pressure that causes others to think on their feet too. So you actually learn a lot better. You're less relaxed and more engaged. When I say less relaxed, I don't mean you're like uncomfortable. You're just like into it. You're in the zone. And it's not just synchronous, it's interactive. So it's not just lecture like this has been. Instead, we do like a lot of games and surveys and challenges. So like we finish this one part and then there's a survey that goes out and you say, well, I think this, and someone else says, well, I think this is better. And then we explore the difference, and then you remember that better and you learn from it. Or there's a little game where like if somebody says this, then someone else has to do that, and we simulate what it's like to code as we interact with each other in the class. And that tends to make things more engaging as well as memorable. I'll also give you challenges and split you into breakout rooms so you can work on projects together in smaller groups, which is also like a great way to really drive points home and make them memorable. We're really big at Inly on making things intuitive. So the concept is rather than just explain something in some kind of theoretical way. Like if you look up something related to math on Wikipedia, it's typically written by and for mathematicians. So it's like very concise, and it makes lots of references to stuff that maybe you don't already know. And it kind of feels esoteric and it's hard to penetrate. That's not intuitive, in my opinion. I think a lot of like deep science or math things on Wikipedia are kind of hard for me to understand. and I have to like really like spend a lot of time reading the same sentence over and over again, or trying out an example before I really get it. So at Inly, what we do is we teach in ways to make things intuitive. So start with something that everyone can relate to, and then step by step build up using storytelling and interactive, teaching. So you're much more engaged to get to a point where like, oh, now it makes sense, and I get the full picture. I now have this foundation and this memorable understanding of whatever the concept is. Maybe it's a for loop, or it's how to Excel looks at files on your computer, so that way you can like access several files when you're writing one Visual Basic script or something like that. We also want the course to be very practical, so it's not just like, hey, you learned some stuff and that was fun. The point is like, and now you're able to add more value at work. So the expectation is you can put this to use on the job right after the course is done. And then you can also add it to your resume with confidence. You can say, I know how to do this and I'm more productive. And if anyone like challenges you or questions you on that, you can demonstrate it to them. You can prove that it's true. And then finally, cheap. So we want this to be accessible to people who are in transition, as well as to firms that are like trying to like stretch their training budgets. So every now and then we'll work with a firm that like, hires Inly to come in and teach a team of people, rather than, just advertising, Inly advertising to the general public. And there's a lot of like thin training budgets right now. So we're like, okay, let's be flexible on that. We issue certificates. That seems to matter to a lot of people. Personally, I think certificates are less important than the skills themselves. And software, even Visual Basic attached to Excel, that kind of software is the kind of skill that you can easily demonstrate quickly. So if you create a project and you share it somewhere online and put a link to it from your resume, that might be more valuable than a certificate, but we do issue certificates. So I said cheap here. I just added this in late last night, so I forgot about it. But I'm offering a discount. Inly is offering a discount on all of our courses right now. So if you go to our website and you enter in this hashtag Inly webinar, that's the discount code. That'll give you $100 off of a course. So let's say, this is a screenshot I took of our website. If you click on courses, you can go in here to sign up. And this is where you would enter it down here. So you can enter that coupon code, hashtag, or hex, or whatever you call this number sign here. And then Inly, capital I, and webinar. And you'll get $100 off. Yeah, so these are our courses being offered right now. This one filled up. So we just added in 2 more of these. There's 2 different courses on here, but you'll see there's a lot of different timings. There's 3 timings for this Python for geo professionals, and there's 2 timings for this workflow automation in Excel, which is what this has been about today so far, this webinar. So typically these courses are like $700 per person. And right now they're $300, and if you enter in that coupon, then, or that discount code, then they're only $200. All right, so enough with the advertising. Let me get back in here to the last bit of content, and then we can take questions. So finally, I want to talk about how to follow through afterwards. I think a lot of courses kind of fall short in this way. You take somebody's course and it's like meant to be professional and practically useful, and then the instructor doesn't do a good job of telling you how to keep the momentum up after the course is done, or how you can really leverage the skills that you've built in the course. So I want to introduce that ahead of time. I want to make that clear to people before they even start the course, and then I want to talk about it during the course too. So just to get a sense of like more perspective on, you take this course and then what? What should come afterward, in my opinion. So first, you keep all the materials, so you should use them. Like for example, this is actually this thing I showed you here with this little happy angel face. This is one of the exercises in the course. So you learn how to write this tool that does this little example here. And there's all kinds of things like that in the course, and you keep all of this material. And so that doesn't just mean that you can refer to it later to like stay fresh and make sure you understand it. These are also codes that you can like cut and paste into your workflows at work to start, automating stuff, or to give you like, how do I do that again? Or maybe I can use this part from this thing that you learned in the course. So you can internalize the why and how by going through them again on your own, but you can also just like refer to it and borrow from it when you're actually getting your work done. So expect to be able to do that. And, I don't know why you wouldn't want to do that. Then you can take advantage of our content guarantee. So the way we see it is, if you buy a course from us, you are buying your understanding of that material, and it's our job to make sure you understand that material. So if you finish the course and there's something you still don't quite get that we covered in the course, then we owe that to you, even though the course is done. So stay in touch with us and ask us questions. You can schedule sessions, or you can send us messages. Like, you don't have to stop learning the material just because we ran out of time. So we've consolidated the courses and made them short, just to like, be respectful of busy people, working and doing this on the side. We've also offered the courses early morning our time and then like evening our time, so that way we can accommodate different time zones. But just because the course goes fast and is consolidated doesn't mean that you have to stop learning from us when the course is done. You can stay in touch and schedule more time with us if you need to. And then finally, I would recommend that you join a community to keep learning and applying these skills when you're done. So explore more with others from the course and from other Inly courses. So we'll connect you with other people who want to be connected. So you don't have to do this if you don't want to, but you finish the course, like, hey, here's a group. Why don't you join that group? And you can ask questions and post things and share with each other what you figured out. And you're allowed to share methods that are built on Excel's Visual Basic. Just be careful about sharing your company's data. Like, you need to get permission typically before you do that. But I put a for loop after a while loop, and I put an if statement after it. That's not proprietary to your company. That's built in with Excel. So you can double check that. Maybe different companies are different, but that's what I've seen so far. So it's good to join a community even outside of your team. Maybe even outside of this course, you can join a community locally or online, just to keep the learning going, because the pace of acceleration in new technology, especially involving software and scripting, is really fast. And so you're not going to want to get left behind. Just because you've learned something new and you've like taken a step forward, you should just keep taking those steps forward. Once you get the foundation, I think, from this course, you kind of won't need any more than that. I think you could keep going and keep learning that stuff yourself afterward. So it's 10:03 my time. I want to switch to Q&A, but I wanted to show you one more example here of Excel and automating stuff. So let's say that this is a bunch of data that you pasted from some tool that you use in your company. And again, don't worry too much about trying to understand what this data means. It's just arbitrary data for now. What matters is the workflow. And what you need is to use Excel to somehow take this data and change the way it's formatted, so that then you can import it into another tool to do some other part of your workflow after that. And the way that you need this set up is for something that's like load 200, you need to go through here and find these things that are joint loads 14. And for FXYZ, MXYZ, you put each of the numbers over here. This is the format you need for each one of these, this number 14 and this number 15, right? But the problem is the way it's set up here is, here's FX, FYFZ, it's oriented horizontally. And 200 gives us this line here, and that's for 14, but 200 is for 15 is this line down here. Oh no. And then, here's 200 for 3198, and it gives us this line down here. This is kind of complicated. Like, and typically what people do is they grab this and copy it and they paste it here. They grab this and copy it and they paste it here. This one, they copy it and they paste it here. And this takes like, hours and hours each week. And if there's one error in where you pasted something, which is pretty easy to do when you get confused, I would get confused trying to do that. Then it's broken and you gotta like spend a long time looking for where that error is, which basically means starting over and repeating the entire workflow. Whereas instead, you can use something in Visual Basic and um, run a script that just automates that process for you. And let's say you have to do this 3 times a week, and every time you do it, it takes you 6 hours because you've gotten really good at it manually. But that's 6 hours of really intense, exhausting concentration that's kind of error prone from a human perspective, right? Whereas you just click a button and you're done. If you build it yourself, build a little tool yourself. So program complete, there's 4 nodes and 28 load cases. Hey, that's great. So that's just another example of something that you can build yourself that is really impressive. And I actually didn't build this one. A student of mine built this to handle somebody else's problem that was shared on a community generally. So really cool example there. All right, so that's all I've got in terms of uh, lecture content. I'm going to turn it over now for questions. It's 10:06. I'll stick around until 10:30 my time, unless others are all dropping off the call. But that's it for me on content, and I look forward to getting some interaction. Now that we're done with the lecture part, feel free, rather than just typing questions in the chat, you can actually like just unmute and turn on your camera and like talk if you'd rather do it that way. So I really want to open it up, and I encourage any sorts of questions or comments or criticisms or suggestions. So thanks for your time. Here's a question. How effective is using this process for dashboards? Um, so if you want to make a dashboard, I think that Excel is kind of like a clunky way to do it. Excel does allow you to have like some um, GUIs, guided user interfaces. So you saw one in the last example that I pulled up. This one, if you run the macro in here, where is it again? That's here. So it gives you like a, yeah, it gives you this little like window, like that's like a message box, and you can choose what's in there. You can make these two-way streets. So you can have a message box pop up where it's like, hey, what do you want? Give me some input parameter. And then when you hit like run or whatever you decide, then it'll finish doing that running part for you. So you've got like a lot of options there for user interfaces. Visual Basic doesn't do a very good job with creating and manipulating graphs. So you can move all the data around and get all the data ready. And then you got to like highlight it and go in here and like insert, I want to make a graph or something. So typically in a dashboard, you'd want both of those things. You'd want, some ability to like choose from drop-down menus or enter in parameters. And then you'd want an ability to like see charts and graphs and things. In Visual Basic, I think it's really hard to do anything like that there. So I'd recommend Python for something like that if you want to build a software product that is a dashboard. I'll say though, in my experience, there's always a ton of dashboard software solutions competing for, a very crowded and tough market. Like there aren't that many companies that will spend a lot on dashboards, and most workers feel like, oh man, if I have one more dashboard, I'm gonna, quit my job or something. There's just so many dashboards. But I'm sure that there are places where a dashboard would be super helpful. So yeah, good luck if you found one of those. That sounds like a cool project. So since there's more time, until I see another question, I'm just going to start showing you some of the content from the course. Let me zoom in here so it's easier to see what's going on. So notice you've got column 1, 2, 3, 4, 5, 6. In Visual Basic, you refer to cells in Excel by referencing their row number, which is easy to see, 11, followed by their column number, which is, E is a letter, not a number. So you've got to count 1, 2, 3, 4, 5. Or if you're really good at knowing what number is associated with what letter in the alphabet, you can be really quick with that. So I've just written those out, column 1, 2, 3, 4, 5. But you can actually, depending on whether you're in a Mac or a PC, you can go to this little options thing hidden down there. And this is the kind of stuff I'd show you in slower speed in the course itself. Go into formulas and you can change something. So now, hey, you've got ones and 1, 2, 3, whatever, and 1, 2, 3 down here. So now you don't really need this little guide. You can just reference, okay, I want to move something from here to here. So say our goal is we want to move this hello world sign. This is the text that we want. We want to move that down to here. This is a very simple thing. Like ordinarily, I would just go here and do, Control C, or the equivalent on a Mac is like that Apple sign, I think, C, and then I go in here and do Control V, and so there's hello world there. By the way, Visual Basic in Excel works the exact same way for an Apple computer as so whether you're running OS X or you're running Windows, it works the exact same way. So you don't have to worry about that. Developer, I can go into Visual Basic here, and this exercise is called moving data around. is the first one. So here's moving data around. And what I might start with in the exercise, if this was the very first exercise for a student, is something that says, here's a variable that we've created, text to paste, and we've set it equal to something in our sheets here. And this seems kind of like arbitrary and weird at first, like, what is text to paste? Why did I call it that? And I put an equal sign, and then what is this? Like sheets one, like what's going on here? So at the very beginning, you have to suspend your disbelief and just like trust it. Like, okay, so I'm going to have to use this sort of sheets thing. And it turns out you use this all the time. So you get really comfortable with it. And this is whatever you want to call it. So we can, instead of text to paste, I gave it that name because we're trying to take some text here and paste it somewhere. Our goal is to programmatically take this hello world and put it in here. If that's our goal, maybe I want to call this variable that's going to read something. This is the sort of control C, the copy part. It's going to read something from my sheet. I might call it text to paste, but I could call it anything else, like it doesn't matter. So, and then I've got sheets 1, cells 15:1. What the heck does that mean? So sheets 1 is going to take the active workbook, which is this one, Visual Basic Scripting Exercises 1, with the answers in them. It's going to take that and look for the first sheet inside of it. And the first sheet is this one. So if I were to grab this sheet and scoot it over here, well, now this is the first sheet. So it would look at this exercise rather than the first one. So what I've done is I've numbered them for you. So this is 1, then 2, then 3, then 4. So that way you can make sure that you don't accidentally like move the sheets around and screw up which one is being referenced. So it's going to reference this first sheet, and then it's going to grab and cells. A cell is like one of these blocks here in this grid, right? So this is cell 4 or 13:4. So we count down the rows and then across the columns. So it's 13:4, right? So this one is grabbing 15:1. So 15:1 means it's counting down to 15. Okay, there it is. And then the first column. So it's going to grab whatever is in here. And this sandwich here, this variable that I made up, this is essentially just a place on my computer, like somewhere on my hard drive. Visual Basic is telling my hard drive, hey, this place, like carve it out and reserve it for a variable called sandwich. And then I want you to take something and put that into this memory storage location. So that's what happens whenever, I could set this equal to 4, and it'll remember that sandwich is equal to 4. And if I ever then ask for, hey, what is sandwich equal to? It'll go to that place on the hard drive and look at what's there, and it'll find, 4, or it'll find whatever this number is here. So the first step here is to create some sort of variable that that is referencing our Excel sheet. And then the second step could be, we could just write, well, sheets 1, and then dot cells. And what cell do I want to put this into again? Let me just scoot it way down. It's cell 20, down to 20, and then comma 1, 2, 3. So 20, comma 3. Okay, cool. So I can say cells 20, comma 3 equals sandwich. All right. So now I'm going to click right here. And again, I'm going really fast. Ordinarily, I wouldn't do this in a course. I just want to be respectful of your time because the webinar is going to end, and I want to get through this quick little exercise. So I would introduce to you like these kinds of things in more of a intuitive like procession, so that you're getting a sense and it's building cumulatively. Right now, I'm just kind of like flooding you with information. But if I run this subroutine here called moving data around, ordinarily it'll just run line by line. It'll first look at this and say, okay, I'm running this thing, and then it'll find that place on the hard drive, or create a place on the hard drive that it'll remember, that it'll associate with the name that I gave it, sandwich, and it'll put in there whatever it found here. And in this case, what it found here wasn't the number 4, or 47 or something. It could have been anything, but we put in this reference to our worksheet here. So it put that in this reference to our worksheet, hello world. And then it moves to the next line and it says, oh, I want to now take, rather than a place on my hard drive, sheets 1 cells 23, which is this sheet again, cells 23. And instead of pointing to some memory storage location and putting something there, instead I want to look at this worksheet and put something there. And what am I going to put there? Well, let's put whatever we found in our memory location on the hard drive in there. So that's how it would work. And if I just hit play on this one, moving data around, let me find it, moving data around, run, you can see now it says hello world here as well. Another little nifty trick, I can put these red things in here called breakpoints. So I'm going to delete this. So it's like I've undone my work there and I want to run this macro again, or this subroutine again. So if I hit play now, and I choose the right one, moving data around, okay. It's turned yellow. So that means that Visual Basic started to go through and do the work, but it stopped when it got to this line here. And the breakpoint, this red dot that I turned on by just clicking over here in the margin, you can like enter one wherever you have some code that you've typed. When it reaches the breakpoint, what Visual Basic does is it doesn't execute the line on the breakpoint. It just comes up until that line. And because this is the first line, it hasn't done anything. But what's really cool about this environment here is now I can just mouse over a variable and Visual Basic will tell me what it's equal to. So right now, Visual Basic knows that there's a variable called sandwich, and that variable is equal to empty, which means nothing. And the reason it's equal to nothing is it hasn't executed this line yet. So if I hit play again, it jumps down now to the second line, which means it's finished with this first line. It actually executed this first line. So now when I mouse over sandwich, I see hello world. And notice I put that in quotes. That's just because of the data type. So hello world is a string, and Visual Basic will encapsulate every string in quotes just to like show, hey, this belongs together, these two words. They're wrapped in this one thing so that, you know, maybe it was a longer string and I had, instead of hello world, I put like, hello world, I'm learning VBA. If that was our string, then if I stop this and start it again, and move on to the second line here, now when I mouse over sandwich, it's hello world, I'm learning about VBA. And then when I press play on the next line, notice there's no more yellow. We're done executing. If I mouse over something, nothing happens anymore. So VBA is finished, and anything that it was temporarily remembering while this was executing, it is now forgotten. And the only thing that remains is this permanent record here, you know, comparably permanent record, where we've like put something into our spreadsheet. So this is the kind of stuff that you would do in our course, but with a lot less lecture and a lot more interaction and more kind of exploratory. So you move on and you can see there's a lot of different exercises here. We move between doing things that are more game oriented, where we're interacting together on Zoom, to the scripting environment, then coming back and then maybe some lecture and then going back again and that sort of thing. But I just want to give you a little taste of what you're in store for, because there is still more time before we ended this webinar. I haven't gotten any questions since then, so maybe I'll hop off for now. But thanks everybody for joining.